Welcome to this brief lecture on examples of K step ahead prediction error models. We will discuss different K step ahead prediction error models. We will start with Rmax. Rmax denotes AYN equals PU n minus K plus C into C of n. AR denotes A, autoregressive, moving average is indicated by C, and X denotes exogenous, that is the external input to the noise model. Recall that we divided C by A and got EJ and FJ. This was the prediction error model that we arrived at. Now let us apply this for Remax. What is Remax? It is of this type. AR denotes as before autoregressive. Then I denotes integrated moving average. Why is that? Because when I divide throughout by delta, I will have no delta here, no delta here, but I will have delta in the denominator. So it is equivalent to integrating the moving average part. So integrated moving average, and of course X is exogenous for this external input. Recall the Rmax model and its prediction error model. So is the solution to Rmax model useful? This is what we saw in the previous slide. There is no integration here, but here there is an integration extra delta term here. Can I use this solution to arrive at the solution for this? So you just have to compare these two, make suitable substitutions and arrive at the solution. So in the place of A, I have to put A delta. In the place of B, put B delta. No change in C. C divided by A is EJ and FJ, except that in the place of A we put A delta, and in the prediction model, in the place of B we have to put B delta. So this step gives EJ and FJ, and I substitute it here, except in the place of B I have to put B delta. So here is the prediction error model for Remax systems. Next we will take Rx model. What it is we will see shortly, but before that, this is what we obtained in the previous slide. So the Rx model is nothing but Remax with C equals 1. So here is the model for that. It is the same as this. I have divided throughout by delta, but in the place of C I have 1 here. So what do I have to do? In the place of C I have to substitute 1. Everything else remains the same. You get the same thing, and similarly the prediction error model also has no change. Only thing is EJ and FJ will be different because now you are dividing 1 by A delta. To conclude, choice of models depends upon the underlying physical process. Prediction error model for each process model is explained. I want you to notice that the same Scilab code can be used for all of them. The Scilab code that we presented in the previous lecture is useful for all of these. I would encourage you to try out various examples, construct examples by yourself and try them out. With this, we have come to the end of this presentation. We will see the applications of PEM in subsequent videos. Thanks for joining. Goodbye.